In this lesson, we're going to continue solving equations that have fractions, but we are going to focus on proportions and applications of proportions. We did a little bit with proportions in the last lesson. A proportion is a statement of equality between two fractions. Don't worry about that I've used a bunch of different letters. This just represents one fraction equals one fraction. And what we know is that the cross products, A times D, has to equal C times B. So let's use that concept and see if we can solve these equations. I have x plus 2 over 3x plus 8 is equal to 3 over 8. This cross product, that happens. I've not figured out what's doing that. That cross product equals that cross product. That means, and it doesn't matter which side you write them on, 3 times 3x plus 8 is equal to 8 times x plus 2. Let's use the distributive property. On the left, we end up with 9x plus 24. 3 times 3x is 9x. 3 times 8 is 24 equals 8 times x is 8x. 8 times 2 is 16. I'm going to subtract 8x from both sides because I like to take care of my variables first when they're on both sides. X plus 24 is equal to 16. Subtract 24. X is equal to negative 8. If I put negative 8 in the place of x, that is not going to become 0, so this is a completely valid answer. Proportions. Pretty easy rational equations to solve. Let's look at the next one. I have 5/3 is equal to 11 over 6x plus 1. I'm going to look at that cross product and that cross product. I have 5 times 6x plus 1 is equal to 3 times 11. Distributive property on the left. 5 times 6x is 30x, and 5 times 1 is 5. 3 times 11 is 33. I'm going to subtract 5 from both sides, and I have 30x is equal to, if I subtract over here, I get 28. I'm going to divide by 30. Some people are starting to feel a little bit concerned about this. X is equal to. It didn't go in evenly, didn't go in at all. That's okay. Sometimes you get fractional answers. You do need to reduce to the lowest terms. Divide by 2. Divide by 2. That's going to give me 14 over 15. And that's not going to make that denominator equal 0. So that is my answer. Let's look at number 3. This is an application problem, but you'll see, I think, that application problems that involve proportions are not too difficult to solve. What you're going to hear in this is a comparison. There are 110 calories per 28.4 grams of cereal. So this is compared to that. 110, and I'm going to put an abbreviation for calories over 28.4, and I'm going to put a G for grams. Any kind of abbreviation that you want. Because when you say it's equal to another comparison, you have to put calories on top and you have to put grams on bottom because these are supposed to be equal. Find how many calories, question mark, X, are in 39.76 grams. 39.76 grams. So when you set it up, you see this comparison and then you see this comparison. That's X calories. I've got my calculator handy. I'm going to multiply 28.4 times X equals 110 times 39.76. So 28.4x is equal to, I'm going to grab my calculator, 110 times 39.76. And I get 4,373.6. And I'm just going to check that one more time. It's always a good idea to do your calculations on your calculator twice. All right, that seems to be right. Now I'm going to divide both sides by 28.4, which is the coefficient of x. I get x is equal to, back to my calculator, that answer divided by 28.4, and I get 154. So if I were filling in a sentence, there are 154 calories in 39.76 grams of the cereal. Okay, let's look at number 4. Number 4 still, it's going to use proportion. It's going to use the concept of similar triangles. When shapes are similar, that means that corresponding parts are proportional. Corresponding parts, 9 corresponds to 4.5, 7 corresponds to 3.5, and 11 corresponds to y. You only need to set up a single proportion. I know that I have to set up one fraction, one ratio that involves y. So I'm going to say 11 is to y as you have a choice. You can say 9 is to 4.5, or you could have said 11 is to y as 7 is to 3.5. They gave us more information than we needed. So you could set up this proportion, or you could have set up this proportion. You had to include the 11 is to y. All right, cross products. 9y is equal to 11 times 4.5. We have 49.5. Divide both sides by 9. And I get y is equal to 5.5. Okay. Looks like I have one more. And it says the ratio is another word for fraction, of an object on planet A to the same object on planet B. So it's going to be planet A to planet B is 100 to 3. A to B. My second ratio will have to be A to B. If an elephant weighs 5,000 pounds on planet A, has to be on top because that's A, find the elephant's weight on B. That would be X. My labels helped me set it up. Now I'm going to get rid of those labels just because they're, well, strange things disappear. They distract. All right. Cross products. 100x is equal to 3 times 5,000 is 15,000. Divide by 100. Divide by 100. X is equal to 150. So planet A, the elephant weighs 5,000 pounds. Planet B, the elephant only weighs 150 pounds. Evidently, there is a difference in the gravitational force on those two planets. So none of these did we have to worry about domain. I kind of kept an eye on it. I didn't say it as often as I should have, but if x is 150, that does not make a denominator equal to 0. So we really ought to always be aware of that. So you've got a few proportion problems to work on as well.